Well, hello everyone and welcome to another tutoring, teaching, education lesson by your girl Audrey. So we have entered into another phase. So last night I was doing a little bit of linear inequalities and then kind of jumped into graphing quadratic functions. And I figured, you know what? Why don't we just stick with that? Okay, so when we're looking at graphing those quadratic functions, I want to kind of do like a quick review so you guys can jump right on it. All right, so last time we talked about the different parts of this shape, which is called a parabola. All right, so when you're looking at quadratic equations, there is always something called a turning point. And that turning point is called the vertex. So I noticed that my graph is open up like a cup. And that means I was going down, down, down till I hit a point and then I pop right back up again. So that was my turning point. So with that turning point, the shape of it kind of tells us a little bit about if we have a maximum point or a minimum point. So as we see over here, when you're open up like a cup, you have a low point. That's your minimum. That was your vertex. But when it opens down like a frown, we have a maximum point. That's my high point, okay? So open up like a cup, minimum. Open down like a frown, maximum. So now, when we cut our parabola in half, that's this little green line. So when I cut it in half, it's being cut by a line. And this line is called my axis of symmetry. And you may see it on some papers written as AOS. So let me get all this stuff together. So my axis of symmetry is basically cutting my graph in half right through the x-axis. So that's why the axis of symmetry is always x equals, because it only goes through the x-axis. So when I'm doing this, if I know what the vertex is, which right now for this one, my vertex is at 0, 0 at the origin. If I want to know what the axis of symmetry is, all I simply have to do is look at the x value of my vertex. So x is going to equal 0. Now, there was another couple of things that was mentioned. It's a little advanced, but we were able to get it done, which is your domain. So the domain is the list of your x's. So my x values, we're only seeing a small snapshot of the graph. So the graph is actually going to keep spanning out and up, okay, all the way to positive infinity. So when we're looking at the domain, we're looking at all values of the x's. That means the whole numbers. That means the numbers that are in between 0 and 1 in the positive section, also in the negative section. So we're looking at all real numbers. And all real numbers can be written basically one of three ways. You can do it verbally, which is just write out all real numbers. Or you have the symbol for all real numbers. And the way that you draw that is you're going to draw two vertical lines and then make a capital R. Okay, so that's how you draw your all real number symbol. And another way is to put it in what's called interval notation. In interval notation, just basically tells me what's happening to the lower part of my graph and what's happening to the higher part of my graph. So since it's all real numbers, it's taking everything from here to negative infinity as well as taking it from here all the way to positive infinity. And the infinity symbols, there's no boundary, there's no end. So that's why we use the parentheses, because there is no boundary with it. Yes, good. All right. So with that, it always gives us, okay, there's also an A value. And that's what we're going to do a little bit more with, like how to get the equation. Okay, when given some information, how do we get the equation? So we can do it what's called, if I slide this over, we can do it what's called vertex form. So we're going to look at things in standard form, and I'm going to show you how to put it in what's called vertex form. And then we're going to do some more practice with the graphs. So that's going to be what's on our agenda for this afternoon or morning or evening, wherever you are. Okay. Yes, it is. But if you try to take it all at once, it will kind of make you feel like it's really hard. But if we go through it step by step and you ask questions along the way, KF4, then I can help you. All right. That's the reason why I'm here. I'm not just here just for shits and giggles. I'm here to help and to assist so we can break all these concepts down. All right. So now let me flip to my pages because I had some other things in mind, but I really want to make sure that you guys get these concepts. So let me unshrink. And if you know of anyone else that's thinking about or going into the graphing of quadratic functions phase and they need a little more assistance, hey, bring them on in, share the live, okay? More the merrier. Hey, all right. So I have finals next month. Any advice on retaining formulas or information from heavy? Well, my suggestion is to make yourself flashcards, especially when it comes to the different formulas. So if I have, like, even if you have just regular white copy paper, and if you can't afford index cards, hey, you can get regular copy paper, okay, fold them. You can fold them into fourths, you can fold them into eighths, whatever it is. And what you need to do is on one side, you're going to write what the formula title is. So say it was the vertex form, okay? And then means on the other side, you'll actually have the vertex form. Now, if you also have your notes, another way to do it is through practice. That's the only way that is going to solidify into your head. So when you do your note cards, then you can use your notes. So let's say, for example, I'm going to use one of my, let's say I wanted to do completing the square, right? So I have a couple problems, a couple examples of completing the square, just saying. And what you can do is you're going to copy this problem and you're going to copy it on, say, a separate sheet of paper, right? So you go, you copy the problem, you write it on a separate sheet of paper. You're going to take your notes and you're going to put it off to the side. And then on that separate sheet of paper, you're going to write out the problem. And you're going to do it step by step, not looking at your notes. So when you do it step by step and then you feel that you're done, that's when you bring your notebook back. And when you do it step by step and then you feel that you're done, that's when you bring your notebook back. And then, sorry, someone wanted to call about I don't know what. Okay. Knowing that I'm not available until like 10 o'clock tonight now. So as I was saying, you do all the work on the separate sheet of paper, then you bring your notes. When you bring your notes, now you can do a side-by-side comparison. And if your answer doesn't match with your notes answer, then you need to recheck your steps. So that's the reason why you guys take down notes. You take down notes to use it to help you to remind you, okay, to use it as a reminder, okay? All right, so my whole thing is index card, old school it. Everybody always wants like the short phrase of it. There is no short phrase of it, okay? So let me see if I can find my stuff, because I have so many things that I want to teach you guys. So I had all that prep. Okay, so what we're doing is we're graphing, okay, from what's called standard form, and then we're going to put it into vertex form so we can graph it. Because once we know what the vertex is and how it should open, we'll be able to figure out what that graph should look like. All right, so my very first example is, we'll use f of x. So if I say f of x, and before I'm starting this lesson, I'm feeling pretty good. All right, and today is the 26. All right, so I'm looking at x squared minus 2x minus 3. Okay. Okay. If I need, yes. Right, so this is actually Algebra 2. Okay, this is actually second semester Algebra 1, refresher again in Algebra 2. So if we are just like not comfortable today. So first thing that I need to find what's called the axis of symmetry, the x value, because I need to find my vertex. And right now, it's really hard for me to find the vertex. So the only way that I can do this is using this formula. Negative b over 2a. And you're probably saying, all right, what's b and what's a? Well, if this is in standard form, my value of standard form is always this. Ax squared plus bx plus c, okay? The a is always the coefficient or the number in front of the x squared. The b is the coefficient for the x or the number that's in front with the sign. And your c is always the constant with its sign. So in this case, our a, I think you guys can see that, okay, our a is going to be 1. If you don't see a number in front of the variable, it's assumed to be a 1. My b is my negative 2, and my c is a negative 3. Okay. Okay. So, okay, you see it now? Yes. All right. So now I'm going to substitute that information into this formula. So we're trying to find the x value of the vertex. So if I do, it's going to be x equals my b, so it's going to be a negative parenthesis negative 2, because I'm only replacing the b with the negative 2. This negative symbol is coming with the equation. Now 2 times my a, and my a is 1. Okay. So now let's do some operation. So we have a negative times a negative. A negative times a negative will give me a positive, and it will give me a positive 2. 2 times 1, that will also give me a positive 2. And 2 divided by 2 will give me 1. So what you just found is the axis of symmetry. So it's basically when my x value is 1, which is right here, I should have a line going right through where x is equal to 1. So that's telling me that my vertex is somewhere on this line. Are we okay? Yeah. Because remember, it's the formula. It's negative b over 2a. You only replace the negative 2 for just the b. So a negative times a negative gives me the positive 2. And then 2 times 1 gives me 2. So 2 divided by 2 will give me 1. This is my axis of symmetry. So I'm saying somewhere on this line is going to be my vertex. Okay? It's a change of sign. Thank you. Now, we need to find our y value. Because remember, a vertex is a point. It's a turning point. So you need your x and your y values. So in order for me to find my y value, that means I need to go back to my equation. Let me make my equation a little more prominent. Okay. I need to go back to this equation and solve for my y value. So I'm going to take this 1 and I'm going to plug it in for the x's so I can find my y value. So if I come over here, so I'm going to say I have 1 squared minus 2 times the 1 minus 3. So this is what our y is going to equal. 1 squared gives me 1 minus 2 times 1 gives me 2. Bring down the minus 3. So now from left to right, 1 minus 2 gives me a negative 1 because we combined these two. The negative 1 minus 3, that gives me negative 4. So my vertex is going to be 1, negative 4. So here's 1, here's negative 4. So this is going to be my vertex. So the vertex gives you the x value, and you use the x value to plug in the function, right? Yep, to get your y value. Okay. All right. We're doing okay so far? All right, so now that's our vertex. Okay, so our vertex is 1, negative 4. So now we need to get our parabola going. So we need additional points. One of the other additional points that we can find is called the y-intercept. Now, the y-intercept is basically where our graph crosses the y-axis. That's this black line right here. So in order for me to find the y-intercept, and if you recall, in order for it to be a y-intercept, your x value is going to be 0. So you can get your y. So guess what we're going to do? We're going to use that equation again. And when we plug in zeros, what do we get as a result? So if I plug 0 in for the x, if I plug 0 in for the x, what would I get for as a result? Hey, just chill. Okay, got 0, negative 3, negative 3. So remember, looking for the y value. Hey, Bridget, negative 3. Arlene, negative 3, just chill, negative 3. Yes. So if I plug the 0 in for my x's, anything times 0 is 0. So I will get 0, -3. All right. Here's a helpful hint. Ready? Your constant is always your y-intercept. Every time. Whatever your constant is, it's always your y-intercept. Once it's all simplified, it'll be it. Yep. Your C is your y-intercept. Thank you. So now we're at 0, -3. That's right here. So here's another. We need another point. Guess what? My axis of symmetry, let me see if I can zoom in and tilt. Okay. My axis of symmetry is like a mirror. So we found the vertex. Okay, we worked hard for that. We found the y-intercept, which is our C. Now we have another point that is a mirror image of this. Okay? Not like the evil image, like the actual mirror image. Like if you looked in the mirror right now, the reflection you should get back is you. If it's not, run. Okay? So the mirror image is going to be what's happening the same distance away, but on the other side. So if I look the same distance away, so this is 1 unit away from the axis of symmetry. On the other side, I need what's 1 unit away from the axis of symmetry. And it's going to be this point right here, which is 2, -3. I think some people were saying that. Yes. Okay, which is 2, -3. Yup, so you just reflect it. I just took the test. Where was this at before? I don't know. It was in my books, I guess. All right. Oh, thank you. All right. So you got that reflective point. Now from here, you could technically draw your graph. Technically, you could. Okay. So a lot of people are like, well, I need 2 more points. Okay. If your teacher says you need to have 5 points, some people like to do it. Some people say, I just want you to sketch the graph so you can see you're slowly getting a U shape right here. And which way is this U opening up? Is it opening up like a cup or is it opening down like a frown? Okay, put it in the chat. Is it opening up like a cup, just based off what we're seeing, or down like a frown? Okay. Okay. So we got opening up, opening up, opening up. Melissa's saying you need 1 more point, then mirror it. You can. You can. You can. But I'm saying, if they say sketch, and I'm talking about those that will be taking maybe the GED, taking the ACCUPLACER, and any kind of timed assessment, the SAT, the ACTs, any of those times, because the way that I teach, I try to keep those in the back of my mind, and I know those are timed assessments. If they say to sketch it, sketch it. You can sketch it right now. But if they're saying, hey, I need 1 more point, you can get 1 more point. And what you could do is, again, using our equation, all right? So I'm going to unzoom a little bit. Whoop. So we can, again, use this equation and just pick any value of x that seems reasonable, okay? That seems manageable that we can use. So if I want to, I could probably use, let's say, -1, all right? So if I just needed another point, I'm going to use -1. So I'm going to go -1 squared minus 2 times -1 minus 3. So you see, I just plugged in something. I just used this side. This side was a little bit lower. So now, -1 squared, that gives me 1. -2 times -1 gives me a +2. Then I bring down the -3. Okay? So -1 squared. If you're putting that in the calculator, you definitely need to put parentheses. Anytime you're substituting a negative number, just use parentheses, okay? So -1 times -1 gives me a +1. So now I have, from left to right, 1 plus 2, that gives me 3. 3 minus 3, that gives me 0. So the point that I just discovered was a -1, 0. So here I go. Here's my -1. There's my 0. So, ooh, clean that up a little bit. Jeez. All right. So now I notice that this point is 2 spots or 2 units away from my axis of symmetry. So 1, 2. So that means I need to be 1, 2 units away on the other side. Did you guys get 3, 0 for the other point? Okay. Hey, Macy. Oh, good. It's good to see you. I haven't seen you for a bit. So you guys think that I don't notice when you guys aren't here. Okay, yeah, that's pretty much it. Yep. So now you're satisfying their precious little souls by giving them 5 points. But notice you didn't have to do the substitution on one side and the other side. One side on the other side. No. Once you find your vertex, find your y-intercept. Once you do that, do the mirror of the y-intercept. Then find another point at random. Keep it simple for yourselves, right? So I just used -1. I could have used 3. That's perfectly fine too. And now that you have everything that you need, let's see if I can sketch my graph. Could have made it a little bit longer, but now I can sketch my graph. Okay. All right. So we took the graph, and I think that's what we'll do today, just work on the graphing part. We took the graph, right? Right, exactly. The sketch does not have to be perfect. It is just a sketch, okay? All right, anytime you're doing any kind of graphing, they want to see if you can get your numbers correct. It's opening up like a cup. That means I have a minimum. And where is my minimum? My minimum is that vertex, okay? So I do have a min, and my min is at that vertex, which we already found, which was at 1, -4. We already found our axis of symmetry, which is my x is equal to 1. It is your x value of your vertex, okay? Then if they want the domain, as I mentioned, domain is your x values. It's always going to be all real numbers each and every time. Okay? Each and every time. All right. Hey, Ryan. Good. Okay? Now, the last part that I want to put in is your range. This is the part that kind of trips people up a little bit, but I'm going to show you. You did all this work to find your vertex. Let your vertex help you. So for my range, I'm noticing a couple of things. Let me unzoom it just a tad. Okay, a lot. All right. So I'm noticing for my range, it's at my minimum, and then it's going upward to positive infinity. So why not use your y value of your vertex to help you with your range? So the range deals with the y's. And right now, my lowest y is at -4. Oh, look at there. It's the same as my vertex. Since it's going up, it's dealing with all the numbers from -4 all the way up to positive infinity. that means we're looking at numbers that are greater than or equal to -4. Okay, good, Melissa, nice. All right, close. Jamina, very close, okay? So there's something that's different, okay? Right, it is including that point. If it wasn't including the point, we would have had a dashed parabola, but we do not have a dashed parabola. We have a solid parabola, so it's including that point at -4. So if I were to convert this information, remember, if you're doing the interval notation, your lowest number always comes first. So I'm looking at -4 all the way up to positive infinity. So my lowest number is going to be -4, and it is going to go to positive infinity, but it's including -4. Okay, since it's including -4, it's a bracket. Infinity knows no boundary, so that's why it's a parenthesis. Okay, just like a closed circle. Yes. Yes, just like the closed circle. All right. Okay, so let me show you my steps so you can take a quick screenshot. Okay, let me show you the steps. So first, move my hand out of the way so it won't be so dark. Okay, find the axis of symmetry. So we're using that -b/2a. Then we're going to substitute that x value into the equation to find the y value. Okay, and what you just discovered is your vertex. Okay, now if you want to find the y-intercept as your next point, you're going to substitute 0 for the x to find your y-intercept, aka it is your c value, okay, with its sign. Now, after you do that, you can plot the points across the axis of symmetry because it's reflexive. Then you can find 2 more points, just basically substituting into your equation. But this part, if you have to go to vertex form, I'll show you that next time. Okay. We're reading domain and range. Do we read off domain from a span of x's left to right? Yes. And range up, down? Yes. But when you're putting it in intercept form, make sure it's your lowest. Okay, make sure your lowest number comes first. Okay, ooh, sorry that this is shaking all over the place. Okay, multiply it and make it simpler in my head. Okay, all right. Let's try the next one. You're probably like, woo, all that for one. Yes. Yes. You're like, we just spent how much time? I'm like, look. Sometimes when you're doing math knows no time. Well, it does in a way. But sometimes that's why when I used to be in the classroom, I would always do the work myself to see how long it would take me to do it. Then I would multiply that by 3 and add 20 minutes, especially for my special ed population. The reason why I did that is because I don't want my students sitting around just trying to spend hours. I love when parents just say, my child was spending 3 hours to do your homework assignment. I was like, why? Like, what? What are they doing? All right. So, oops. This time I have a 1/4. And of course, we knew I was going to bring a fraction into it, but we need to. So I'm just going to simplify it. I'm just going to keep it as y equals 1/4 x squared plus x minus 6. Okay. So let me unzoom a little bit. Get you guys centered a bit. Okay. All right. So 1/4 x squared plus x minus 6. Okay. Coming over our very first step, we're using this formula. Let me highlight it so you guys can get it. Okay, so I forgot who asked me about memorizing. So that means this has to be one of your formulas. Okay, if you want to, you can write an example with that one formula. Okay, so you write the formula, the name of it on the other side, but you're on the backhand side, you write the formula, and then you write an example of how to solve it. So here's one example. So we are trying to find my A, B, and C. So let's list it. As soon as I can grab my pen. So we have an A, we have a B, and we have a C. Okay, what is my A, what is my B, what is my C? Go ahead, you could just list it. The first number, the second number, and the third number. If you want to separate with commas, you can do that. Okay, what is my A, what is my B, what is my C? Okay. All right, so remember the A is the coefficient of the x squared, the B is the coefficient of the x, and the C is your constant. Okay, good. Good. Very nicely done, ladies. Okay, 2 hearts joined. Oh, that's cute. Okay, so we have our 1/4. We have our 1. Everyone always says, well, x equals 1. No, x can be any number. It could be positive, could be negative, could be a decimal, could be a fraction. The coefficient of x is 1. Okay, so just want to make sure I emphasize that. Okay, so now that we have this information, we're going to plug it into our equation. So we have our x is equal to negative with our b over 2 times what is our a. So our b is 1, our a is 1/4. And you're probably saying, oh God, Audrey, what? Now patience. Negative times 1 gives me a -1. So let's think. 2 times 1/4. 2 times 1/4, let me put this as a side note. 2 times 1/4 is the same as saying 2 times 1/4. Anytime I have a whole number being multiplied to a fraction, make that whole number into a fraction. If you feel comfortable, multiply the numerators, so that'll give me 2. Multiply the denominators, that'll give me 4. Both 2 and 4, they're even numbers. So that means they are divisible by 2. This is how you can reduce. So this will be reduced to 1/2. So you're probably saying, well, Audrey, it's a -1 over 1/2. How do I do that? It looks crazy, right? Couldn't we do 1 and multiply by the reciprocal of 1/2? Okay, what's the reciprocal of 1/2? 2 over 1. So 2 over 1 is exactly the same as saying -1 times 2. I know I'm doing a elongated way of doing this, because trust me, I got the answer beforehand. But again, that's me doing it. There's probably some other people that are like, oh, I've never had anyone explain why. Everyone is so used to a teacher that's like, oh, okay, we got -1 over 2 1/4. Okay, so that gives me -2. And you're just like, how the hell did you get -2? Right? So this is why I show these steps. Okay. Is it a long way around? Yes. Okay. Could I just simplified it a little bit better? I probably could have. Okay. But I want you to see where everything is coming from. So in actuality, this x is going to equal a -2. So my x value is -2. Okay, I'll leave this here for a second so you guys can see that. So this is saying that my axis is symmetry, and if you notice, counting it, it's right here at -2. Okay. Keep, change, flip. Yep, you can do that. So here's my axis of symmetry when x equals -2. Okay. Let's see. Yep, multiplying by the reciprocal. Good. You can multiply by the reciprocal if the numerator is a whole number 2. Yep, it's because it's over 1. So, yep. Single fraction over a single fraction is valid for multiplying the reciprocal. Yep. Yes, you can. All right. So we found our x. Now we need to find our y for that vertex. So we're going back to the original equation. We're going to substitute this -2 in for our x's. So if I write it out, it's going to be y equals 1/4 times, we're going to put the -2 in there, plus we're going to put the -2 in for the x, minus 6. So let me stick the -2 in. All right. What should I do first? This is what gets a lot of people. What should I do first? The exponents. Hey, Leanne. The exponents. Yes. So we have to do this -2 squared. Yes. Vital. There's so many people that be like, oh, 1/4 times this. No. Okay. We have to do, please excuse my dear Aunt Sally. Okay. Inside the parentheses, we don't have anything, but the exponents we do. So this is basically 1/4 times -2 squared, which gives me a positive 4, plus my -2 minus my 6. Now, 1/4 of 4 is the same as saying 4 divided by 4, okay? So that gives me 1. So that means we have 1 minus 2 minus 6. Okay, hey, cool kid. Ooh, okay. I hope you're feeling all right. You had surgery and you're watching math? I'm trying not to make you laugh because I don't know what you had surgery on and don't need to bust any stitches. And you came to see me? Oh my goodness. So now 1 minus 2 gives me a -1. And -1 minus 6, that gives me a -7. Okay? So our vertex is going to be, our x value was -2, our y value is -7. So that point, our turning point, aka our vertex, is going to be right here. So -2, -7. All right. So now we need our y-intercept. So our y-intercept, remember, is going to be our c value. So the x is going to be 0, but what's going to be the y? Melissa's like in my head. Okay, why did the -2 turn to positive with the exponent? Because remember, -2 squared is -2 times -2. And a negative times a negative gives me a positive. Yes. With multiplication. There you go. Good. So our y-intercept is basically our c value with the sign for the y-intercept. So it does give me a -6. So our y-intercept is at 0, -6. So we're looking at this point right here. Right. It's a very scary place, Melissa. Very scary place. All right. So now we have this point, which is 1, 2 units away from that axis of symmetry. So that means we need to find its mirror image, which is 1, 2 axes away, or 2 units away from the axes. So that means the mirror image is going to be at -4, -6. Don't be disappointed. All right. I was really bad at math, so I went to Khan Academy to reteach myself. Okay. So write it down. There you go. Okay, awesome. Because you had that drive and determination, cool kid. That's what I'm saying. Khan Academy is a good way to practice, but sometimes you got to make sure you know what you're doing because there are errors, especially with exponents. There's a couple of his videos that I used to use, and I like to watch them before I showed to the students. And he had, what was it? I think it was a to the 2nd times a to the 4th, and he said it was a to the 8th. When you're multiplying, you add the exponents, not multiply the exponents. So I wrote them, and I remember a couple years later, the thing was still there. They didn't change it. So, yeah, I just use it with a grain of salt. Everything's not perfect. Everything's not perfect. All right, well, thanks. All right, so now we can kind of see the parabola, and it's a little bit wider than the other one. All right, and I'm going to tell you the reason why in a moment. But we always like to have, one more? Let's see if we can find one more point to put on there so we can get the reflexive. So all we're doing is we're going to the formula. Now, this is when it gets a little crazy. All right, this is when it gets crazy. You notice that you're going to have to square your x. Okay, you notice you're going to have to square that. So don't pick, say, -3. Because if you pick -3, -3 squared is going to give you 9. And you're going to have to multiply that 9 with 1/4. Or AKA, you're going to have to divide that 9 by 4. That's going to give you either a fraction or a decimal. Make it easy for yourself. If you notice that this is an even number, you want to plug in with an even number. Trust me. So let's say we can plug in, let's say a +2. Because we did the -2. Why not do the +2? So if I come here, I got my 1/4 times 2, and I square it, plus 2 minus 6. Because now, when I use the positive 2, the x, which is this point here, 2 squared is 2 times 2, which gives me 4. 4 divided by 4 gives me 1. See how much nicer that is? So, like, if you did a 3, or if you did an odd number, then you have to square it. Now you're dealing with fractions and decimals. Blech. Who wants that, right? Make it easy for yourself. Now I got my plus 2. Oh, isn't that lovely? Okay. Now I have my minus 6. 1 plus 2, that gives me 3. 3 minus 6 gives me a negative 3. So the next point that we're looking at is going to be 2, comma, negative 3. So then I come over here, here's my 2, here's negative 3, and I'm making this point. So now this point is 1, 2, 3, 4 units away from the axis of symmetry. So that means I just need 1, 2, 3, 4 units away from the axis of symmetry to mirror that point. Now I can see it. Okay, now I can see it a lot better. All right. So some people are like, oh, well, you could use the x-intercepts. Yeah, but that's when you have to have your equation equal 0. And people, let's be real, a lot of people don't like fractions, and it's okay. You can figure your way around it. Don't make it into a decimal because that's just going to throw you all kinds of off. Okay? If you want to, go ahead. But I don't like it. All right? So now from here, I can sketch my parabola. Okay? It's opening up like a cup. So does that mean my axis, does that mean my vertex, is it a max or a min? Okay. Smoothly. Min, good. Min. Awesome. All right. So that means we have, I'm going to stick it right here. So we have a minimum, and it's at my -2, -7. All right. So we already have our axis of symmetry. We already know that our domain, no matter what, I'm just trying to put it in your head. My domain is all real numbers for quadratics, every single solitary time. Now, my range. Okay, my range. What do you think would be my range? You can write it as an inequality, or you can write it as interval notation. What would be my range? Yes, your minimum is called the vertex, or the vertex is called your minimum for this case. The reason why, it's the lowest point. Now, if this graph was upside down like this, my vertex will be the maximum because it's the highest point. Okay. 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 So you really have to practice with writing and using cue cards. That's the only way you're going to remember the formulas. And then try to see if there's a pattern within them. Okay. Yes. Okay, so what would be my range? Okay, Melissa's saying -7 to positive infinity. And she's putting the bracket with the -7. Oh, well, thank you. I try. Try to keep it entertaining. Okay, so we're also agreeing with -7 to positive infinity. Okay, with the bracket on the -7. All right. Okay. All right. So I see two people saying that. Do I have a third? I tend to do things in threes. Okay. And also use the y. So since it's opening up like a cup, it's going to be greater than and equal to. So since -7 is the lowest of the y's, because everything is going up, that means you'll have -7, comma, positive infinity, and there is a bracket around it. Okay. All right, good. All right, what's that symbol meaning by the word domain? Oh, this means all real numbers. Just chill, all real numbers. So you can either write it as the double R's, which is basically two sticks with a capital R drawn over top. Or you can do an interval notation, which means negative infinity, positive infinity. Okay, those are acceptable. Okay. All right. Okay, good. All right, let's try one more. You're like, man, I know. Takes me about an hour to do 2 problems. I know. It's like, will you have any tutoring Zoom calls this Friday? Zoom calls? No. All my tutoring calls are on Mondays for you guys, for TikTok. So I have like 8:30, I have a 1 and 8:30. But a private one, the next available would be Saturday or Sunday. Yeah, Friday is booked up. Today is ridiculous. I don't think I'll be coming on tonight. Thursday night, I will be here. But we can do that. Okay. All right. Okay. Why is it a bracket and why on the left? Okay. Bracket means it's including. So think about when you did the number line with the open circle and the closed dot. So you're including -7. So it's closed. And you always put the lowest number on the left. Okay. All right, Lisa, answer my question, please. Where is your question? So the graph represents the range. The graph represents both the domain and the range. Okay, so for it going up and out, that's representing the domain. From the vertex opening up, that will be your range. So it's representing both. But since it's a U shape and it's going to keep spanning out, it's touching on all your domains, all your x values. Was there another one before that? Because that's the one I see. Okay. All right. So tap a little bit more until I'm going to set up the next problem. And so while I'm doing that, go ahead and tap it up. Let's see. Y equals which one I want? I want this one. Okay. So separate two. Okay. Okay. All right. So my next one is y equals 2x squared minus 2x minus 5. So y equals 2x squared minus 2x minus 5. Okay. Thank you so much for the love. I appreciate it. All right. So now, another pen. Oh, okay. First thing that we need to find is my axis of symmetry. Ooh. Hey, Willie G. It's been a minute. Okay, there we go. All right. So yes, so Melissa's already on it. So first thing, we need to indicate what is my A, what is my B, what is my C. So your A is positive 2, your B is negative 2, and your C is negative 5. So for our formula, we need our x equals, we have our negative times the B over 2 times the A. So our negative B, that gives me a negative 2. My A, which is also 2, but positive. Let me zoom. Ooh, that was a little too crazy with the zoom. A little too crazy with the zoom. Okay. So now we have a negative times a negative. That gives us a positive. And 2 times 2, which gives me 4. So this can be reduced to what? No, right now we're not substituting into the equation. We're finding our axis of symmetry first. Okay, so we're not adding in the x squares. Not yet. We're just looking at the values in front. Yes. Good. Good. Okay, so 2/4, both of them are even, so I can divide them by 2. 2 divided by 2 gives me 1. 4 divided by 2 gives me 2. So we got our 1/2. Good. So this is the x value of our vertex. Now we need to find the y value. So for us to find the y value, we need to substitute this 1/2 in for the x's. So we have 2 times, we're going to have our 1/2 squared minus 2 times that 1/2 minus 5. So put our 1/2 here and our 1/2 here. So that means we have 2 times 1/4 minus 2 times 1/2, that gives me a 1 minus 5. So 2 times 1/4, that gives me 2/4, just like how we did earlier. But 2/4 can be reduced to 1/2. So So you have 1/2 minus 1 minus 5. Now, yes, you definitely want to have a common denominator. You're like, ugh, Audrey, why do we do this? Okay, so just in case you can't use a calculator, this is what you're going to have to do. Anytime you're adding or subtracting fractions with whole numbers, we got to change these whole numbers into fractions. So that means this is going to be a 1/2. We need a denominator of 2, so that means 2 divided by 2. 2 divided by 2 gives me 1. Okay, so we're keeping the value, but we're just changing it into a fraction. Minus, so what divided by 2 will give me 5? That will be a 10, because 10 divided by 2 gives me 5. Or think of it this way. You know you need a denominator of 2. You know you need for it to equal 5. Just multiply the 5 and the 2 to write your numerator. Okay, good. Good. Okay, so Willie, the only way we can add or subtract a fraction with whole numbers is we got to change them into fractions with a common denominator. So this had a denominator of 2. That means these other 2 terms need to have a denominator of 2. So now I'm converting the whole numbers into fractions with a denominator of 2. So when I combine, I'm just focusing on basically the numerators, because they all have a same denominator. So 1 minus 2 gives me a -1. -1 minus 10, remember, when you both have negatives, that means you're adding them, and you're keeping the sign. Okay? So you got your 1/2 and your -11/2. So if you want to make these into decimals, knock yourself out, okay? But all I know is my axis of symmetry was 1/2. Here's 1, so 1/2 got to be somewhere smack in the middle. And what did I use? I used purple. So this is my axis of symmetry. That's my x is equal to 1/2. We found the y, which is 11/2. So 11/2, that's 5.5. So it's roughly -5.5. So here's -5. So 0.5 will be somewhere in the middle here. Okay. So that's going to be my vertex. So 1/2, -11/2. Okay. Hey, Chaser. Okay. Not a problem. Okay. So this was my axis of symmetry. That was at 1/2. Then 11/2 or -11/2 gives me -5.5. So in between 5 and 6. So random dot. So now we need our y-intercept, which I'm going to go all the way over to my c. And my c was -5. So that means my y-intercept is going to be 0, -5. So here's 0, negative 5. So if I drew this properly, 1/2 a step, then 1/2 a step. So that means my other point should be roughly here. My line is a little slanted. Okay, it's very slanted. I'm not even going to lie. Okay, if I drew this, it should have drawn a little bit over to the left to make it a little more perfect. Okay, how'd you get with 1/4? How'd you get to 1/4? So 1/2 squared. Okay, 1/2 squared, that means 1/2 times 1/2. So 1 times 1 will give us a 1, and 2 times 2 will give us our 4. Okay, so 2/2 gives me a 1/4. So then if I take 2 times 1/4, that gives me 2/4, which will give me my 1/2. Okay. All right. So now we need another point. Let's say, I don't know. Let's say -1. All right. So let's say -1. So I'm going back to my original and I'm plugging in -1. And let's see what that would give me. So -1 squared, that gives me a +1. So 2 times 1. -2 times -1 gives me a +2. Minus 5. So 2 times 1 gives me 2. 2 plus 2 gives me 4. And 4 minus 5, gives me a -1 back. So the other point that we're looking at is -1, -1. Let me unzoom just a hair. Sorry. Okay, so here's my -1. Here's my -1. We got a point right here. And that is 1.5 away. So here's my half and here's my 1 here, which gives me at 2, -1. Okay. If you don't believe me, you can plug in the 2 for the x's. So 2 squared gives me 4. 4 times 4 gives me 8. Okay. 8 minus 4 gives me 4. 4 minus 5 gives me -1. So now that we have our parabola, we can just go ahead and sketch our graph. A little wonky, but I think we got it. How did you get -2? Okay. So the formula is -b over 2a. Our b was -2. So all you're doing is replacing the -2 with just the b, not that whole numerator. So that means there is a negative that's outside the parentheses. So negative times negative will give me a +2. Okay. Why do we need to do that process in the beginning to get 1/2? Well, we need to know where is our vertex. Okay, good, Willie. So we need to figure out where is our turning point going to be. So we want to find this axis of symmetry, that purple line. That goes right through our turning point, our vertex. So the reason why we're doing that is we need to figure out where is going to be our turning point, because our turning point can be anywhere. Because if you notice that the other ones, my turning point was here, And then my turning point was here in the fourth quadrant. This is in the fourth quadrant. This is in the third quadrant. This is back to the fourth quadrant. So in order for us to figure out where we're going to sketch our parabola, we need to figure out what our vertex is. So you did that to find your x value of the vertex. Then you use this to plug into the equation to find our y value, which that's how we got our -11/2 or -5.5. So that helped us define what our vertex is. Okay. We need to do this process every time for these kind of problems. Yes. If they're saying to graph it and they give it to you in standard form, yes. Every time. Okay. All right. All right, everyone. Okay, so that is what we're doing today for the graphing of the quadratics. Yes, we did 3 problems. And yes, it took us an hour and 15 minutes to do it. But that's okay, you know, because once you get used to it, you get quicker at it. But I want you to at least understand like the basis of it, okay? So when we're doing this process, you're taking it step by step. All right, so again, here are your steps. So you need to find the axis of symmetry. After you do that, plug it into the equation to find the y value so we can get the vertex. Once we get the vertex, write down what your c is, plot your c. Your c is going to be your y-intercept. So that's another point that's going to be on that graph. Then you're going to plot the points across the axis of symmetry. You can find 2 more points by just looking for one. Okay, just looking for one and then using the axis of symmetry to find the mirror of that image. Once you do that, go ahead and sketch your graph. Okay, vertex form, I'm going to teach you guys next time. Okay, all right, so I have my marathon. I found you. You really helped me understand. Oh, not a problem, Melissa. Not a problem. Okay, the other 2 wasn't here for them. Yes. Now, here's a couple of things. Because soon enough, because I need my finances. I'm not going to sit here and lie to you. You know, it's great to do these things on TikTok. I'm thinking about selling my notes for like literally $2. Like when I do not just one page, that's crazy. But like say if we're doing linear equations, so anything with slope intercept form, finding the slope, standard form, any of those things, that would be one packet. And you can get it for like $2, right? So that's coming soon because people are asking for that. Now, if you don't want to wait, all of my lives are on my YouTube channel, okay? So even last night's live, that's up there now. It took me, when was I able to put it up? Like 12:30. And we finished the live at like 10:30. And as soon as I finished tutoring, I was putting it up and it took almost 2.5 hours. You've been good. Like it's crazy. Do you do trinomials and difference of square reviews? I can. Okay, I can. I saw someone saying something about difference of cubes. Definitely can. All right, so if anything, if you can, let me close this up. If you like how this book is defined, I know it's kind of like crammed in the middle, but this is a textbook or a notebook that I designed. Again, shameless plug. So I try to keep all my notes in here. If you ever want to have a notebook of your own that you can put formulas on one side, steps on another side, and then examples, you can basically literally copy and paste problems inside your book. It has a grid part as well. If you're not good with your multiplication tables, I have your factor sheets from 1 to 200, okay? And then also I have some of the rules of integers, also the words that are usually used, the terminology and word problems. Then we actually took a look at standard form. Hey, there it is. We take a look at standard form. We're looking at that. We're also looking at the standard form for quadratics. Okay, this is what vertex form looks like. Hey, this looks familiar. Axis of symmetry. And then our vertex form. Then we also have the order of operations, not only in the US, but also internationally. Their properties of exponents. So a lot of the things that you kind of have seen in some of your classes, I designed this for 7th through adults. So yes, there's a lot of other things that can be dealt with, especially the trig. I went to a certain degree, but I think the next book that I'm going to do is going to do it a little bit further with the trig, as well as I give you a couple sections just of brain breaks. Okay, just everyone needs to just breathe for a second, refocus, especially when it comes to math. So I'll give you a little bit of brain breaks to kind of help with that. So it's great for homeschool parents. It's great for adults going back to school. Just give you the design of it. If you want, you can get it through Amazon. You can go to the link in my bio, go to my website, and it'll actually have a link that goes directly to Amazon for all my books and all my products. But if you need the YouTube channel, hey, right here, go to Audrey Codner ACG Math Tutoring. That's where I put all my lives. So as soon as I'm done here, I have a client, but I'm going to try to upload it. So then I'll go and do my thing. And once it's completely uploaded, I will put it onto my website or to the YouTube channel. So go ahead and subscribe. If you want to support me, this will be another awesome way. If you can give me a Google review, ACG Math Tutoring. This is basically tutoring, right? You're basically getting free tutoring. I normally charge $87 an hour. And the reason why I do that is because I'm good. I get results, and I get results quickly. And of course, this time of year, a lot of people are trying to get the last bits of their grades raised up because the quarter is about to end soon. And so right now I am really jammed. But if you do, I also, just for TikTok, just for you guys, I have the study group. If you want to be involved in the study group and you want to ask some questions, go to my website. It literally says TikTok study group. Click anywhere on that page and sign up for a slot. So it's Mondays, is Eastern Standard Time, is either 8:30 a.m., 1 p.m., or 8:30 p.m. And the study groups, I'm blocking off a good 2 hours. So you have to submit to me, what are you working on? So I can see what you're working on ahead of time. And then we work out the problems individually. Okay. So then it'll usually be a Zoom call. So I can see your faces, because usually your facial expressions, if you don't get something, shows up before you say, oh yeah, I'm fine. Meanwhile, you're crying in the corner. Okay. No crying in the corner. Okay, good. How much? I think it's 12. Of course, I don't get that much because Amazon takes a good chunk of it. And then plus how thick it is. Look at the thickness. Okay. Most of it goes into, shipping. So I definitely want it. So we have this one as well as my famous one, which is the multicolored one. And again, you can put your notes. I write big so you guys can see it. You don't have to write this large. Okay, so you actually have all of this supporting. And I'm thinking about selling some of my notes so we can see how we can get everything. All right, so I hope you got everything on there. If you didn't, go ahead and take a quick snip. But I will be back tomorrow. What time? It says tomorrow at 1. I might be doing 2 sessions tomorrow. Because so far I haven't heard from this other person that's later on the night. I might be able to come on a little later, probably around 9 on tomorrow night. But I definitely will be here 1 o'clock tomorrow. So you got me for 1 o'clock, and possibly, don't hold me to it, but just be on the lookout. You might see me at 9 o'clock on Thursday. Okay? Yeah, it seems like a lot of people want to come on later. All right. Is there any questions? So far that I'm seeing, and correct me if I'm wrong, that I am seeing like the sum and difference of squares, but I think I did that. Check my YouTube channel. Check my YouTube channel to see if that has been, because I remember I did factoring of trinomials, and I think I did difference of squares. Okay, but I think a lot of people are starting to get into the quadratics. And I know the quadratic, the next one is going to be vertex form. Like how to read vertex form and do the transformations. That's going to be a big piece. So I'll see if I can, slip some stuff in. But I don't know. I can do what I can do. I can only do what I can do, people. I'm only one. All right. Okay, so if we can get it up to 8K before I skedaddle, I do need to go in at least 4 minutes, if not sooner, to clean up all of the shenanigans so I can get myself ready for tonight. Or for my session. That would be amazeballs. Okay, and do not forget if you ever get stuck and you're just like, oh my gosh, Audrey, I don't know. I need help. It's just like, I just need help. Okay. So the help isn't free, but I will definitely give you a major discount. Especially if I know you're coming from TikTok, because you guys have done a lot for me. But, if you can do a Google review, that will be amazing. So at least I can draw in more people that will actually pay my price and pay my worth. And then if you can subscribe to the YouTube channel, that would be awesome as well. I think that's all I can do. Robotic calculations. I don't know, chill. I appreciate that. But sometimes, like yesterday was a chore. Oh, today's going to be a challenge. But God's blessing me. God's really blessing me. Putting me in the right place. I think he told me to be here like a month ago. I started in February being serious about doing step by step. And to hear people saying, I passed this class because of you. You have no idea. No idea. I really do appreciate that. Okay. Oh, 9. Thank you. 9's good. 9 is perfectly fine. So, if anything, keep being confident. I know a lot of you guys are going into a world that you're not used to, and I'm going to be truthful. I used to suck at math horribly when I was a kid. It didn't really dawn on me until 25. I was a special ed assistant, and I was 4th period. I will never forget. I was at Overly High School. And I was sitting in a classroom trying to work with one of my special ed students, and all of a sudden the teacher was like, yeah, we're going to work on fractions. And I'm like, oh, God, I don't know how I'm going to help this child. And all she said was, it's just fractions is nothing but division. And I don't know why that opened up the clouds. I have no idea. But all of a sudden my fear subsided, and I was like, oh, my gosh, that's it. And then I felt like, once I understood and I had someone to explain what was going on, I was able to do the calculations. And I think that's why I really wanted to come on TikTok, so I can be that person. I know there's several other people that will kind of know how to differentiate equations and how to find the derivatives of all these weird functions. And yeah. I feel like I want to speak to the people that feel that they are cursed by math. I want to talk to the people that feel like I just can't do it. And I'm like, you know what? Do you have kids? And they all say yes. And I'm like, I need for us to break this curse, because it's not a generational curse. It's because you were presented with this information. You felt like you have questions and you either were too scared to ask the questions or you didn't know what question to ask. That happens all the time. All right. But by having someone that you can like feel comfortable, hence the music's a little slightly in the background, just really don't have to be like, yeah, I can throw out math terminology, but if you don't understand what I'm talking about, what's the freaking point? Right? So I just feel like by me breaking this stuff down, now when your child comes to you, you can say, I think I know what to do, and you don't feel so like defensive. Like now you can say, yeah, let's just work this out. Or you can say, hey, I know the perfect person. Let's go ask Miss Audrey. But now you don't feel like you have to say, oh, well, I was never good at math. Your dad was never good at math. Your grandmother. It's like a generational thing. Like, okay, your great-great-mother, twice removed cousin, they weren't good at math either. Man, you don't even know that person. You're just like, yeah, they weren't good at math at all. Right. Oh, all right. Oh, blessed RN. How are you? Now, if some of you guys are trying to trying to figure out how to do the calculations or do certain calculations, especially for dosage, go ahead. I know I've always talked about blessed RN once in a while. Please follow her. She has this simple concept for you to understand how to do dosage. If you're trying to be a nurse and you're like, oh man, I can't do the conversions, this is making me crazy. If you're thinking about getting your TEAs, okay, you need to go and check out her lives. Okay, I learn things and I'm like, oh, okay, oh, that's a shortcut, I like that. All right, but I'm not gonna steal it. I'm going to give credit when credit's due. Okay. So if you're not, go ahead and check out a blessed RN. Okay. And there's a couple others. If you have younger students, or if you just want to learn a different way on how to count, how to add, how to subtract, how to multiply, and she's learning how to divide. I taught that man. Yeah, she did. Right. There's always tricks and tips. Everybody's got to. I have my friend learning with Lynette. Okay, she does math using the abacus. Okay, I know a lot of you probably like, what the heck's an abacus? If you ever text, let me see if I can find. Yeah, I can find it right here. All right, so I just put it into the chat. I think. Nope. How about now? There we go. Okay, it's a little square, but it looks like a whole bunch of beads on there, and people are counting, adding, subtracting. The reason why you need to have some kind of visual representation of what is math. Like, okay, everyone knows, wow, that went across the room. Everybody knows that's one pen. Okay, then you have 2 pens. Now you have 3 pens. And then you have 4 pens. Okay, but she has the visual representation, so now we can understand why these numbers are connected with this many quantity. And the way she does it, and to show you how to do the distributive, she's actually doing some stuff and teaching some people on her live. She goes live like almost 3 times a day. She talks about me, 10, I'd say. She's probably watching now, right? There you go, Bridget. Yes. So if you have anybody, maybe it's yourself, that want to learn how and just have fun with it, go to see Learning with Lynette. She's awesome. All right. So if you guys want to continue with math, I'm going to stop right here. But you can actually go to my friend, Imagine. I always get her things. I think it's Imagine Math. She's on right now, if I can find it. Yeah, I got to clean my desk off. It looks like a bomb hit it. All right. But I think Reimagine Math. No. Who knows it? Who came from her? I know her name is Evelyn. Something Math 19. I'm going to forget about it. But she's on right now. So check out her stuff. And especially if you're thinking about doing the ASVAB. Yes, thank you, Bridget. I can never remember impact. Impact math. Because she makes an impact. That's all it is. Okay, so she's doing impact math 19. So she's on right now. So if you want to keep the party going, go ahead and head over to her room. And then I will see you guys tomorrow. Yeah, it's definitely not going to be tonight. It's not going to be a shock. Okay? All right. Love you guys. Keep being awesome. And I will see you guys tomorrow. All right? Toodles.